Okay, pre-cal students, in this video, we will be finishing up the word problems in chapter 1. As I said in the previous video, please work hard, especially on the homework, okay? Especially on the homework. Your heading for today is word problems chapter 1. Word problems chapter 1, and be sure to include today's date. Okay, be sure to include today's date so that your notes are organized. Now, students, we'll be looking at only 2 word problems today. 2. The video will not be long, but the homework will be where most of the learning will take place. As you will be asked to reason, problem solve, and think, again, like I said up here, please work hard. Use the homework help video to help you. Word problems are challenging, but you can learn from the notes that I give, and you can learn from your homework, okay? Alright, let's not waste time. Let's jump right into this. Here's the first word problem. Please feel free to write this in your notes. In fact, I want you to write this in your notes. So in your notes, write down page 105, example number 8. Page 105, example number 8. And then you have a choice. You can just watch the screen and take notes, or you can turn in your book if you want to page 105 and see the word problem there. Either way is totally acceptable. Okay, here we go. The number n of bacteria in a refrigerated food is given by this function here, n of t, n of t, where t is the temperature of the food in Celsius. Now let's stop right there. Let's break this thing down, okay? Now, it says n is the number of bacteria, t is the temperature. So what does this function do? It gives you, I can give you the temperature of the food. And then you can tell me the number of bacteria. Okay? That's what this function does. I mean, look at it right here. It tells you n of t, number of bacteria based on the temperature. So I tell you the temperature, and you can tell me the number of bacteria. Now, notice your temperature has to be between 2 and 14 inclusive, okay? But if I give you a number in this domain, you can put it in and tell me the number of bacteria. Got it? So we have number of bacteria based on what? Temperature. Number of bacteria based on the temperature. Alright, now let's continue on. When the food is removed from refrigeration, the temperature of the food is given by this function here, T of T, where little t is the time in hours. So let's talk about this for a second. Please take some really good notes on this, guys. Please take really good notes on all of this. See if this makes sense. I'm trying to break this down for you. Now, capital T stands for the temperature. Little t stands for the time. So what I have is temperature based on time. In other words, I can give you a time, and you can give me out the temperature of the food. Okay? And then, once you give me the temperature of the food, I can plug the temperature in over here and tell you the number of bacteria. Okay? So, this function here is the temperature of the food based on T, which is time in hours. In other words, it says when the food is removed from the refrigerator. So once the food is removed, every hour that goes by, I can tell you what the temperature is. Now notice your time has to be between 0 and 3 inclusive. Okay? Alright, there we go. Now, step 1, letter A says, find the composition or the composite of n of t of t. So we have our n function and then our t function. We're going to find the composition. No big deal. Piece of cake. Are you ready? Here we go. First of all, students, understand my first letter in my composition is N, so I'm going to write the N function. Everywhere there's a T, I'm going to put a really big parentheses. Okay? We should be pretty familiar with this. And I messed up there, didn't I? There's a T here, so we put a pretty big parentheses. Now, look at my composition. The next function is T, so I pick up my T function and I put it into the two parentheses. Okay, so here we go. 4T plus 2. 4T plus 2. Now, this is easy here, guys. We have 80, negative 80 being multiplied through, okay? So, negative 320T minus 160. And then bring down your 500. That's pretty simple. Negative 80 times 4, negative 80 times 2. Alright? Now, over here I have a problem. Before you multiply the 20 through the parentheses, you must first square this parentheses. So when you square this parentheses, it's really like having 4T plus 2. 4T plus 2. Okay? So if you do all the work you're supposed to do, trust me, you'll get this right here. Alright? You will get... Let me write that again for a second, just to make sure there's no confusion for you guys. Now when I take 4T plus 2 times 4T plus 2, you guys understand? Take the 4T, multiply it through. Take the 2 and multiply it through. Okay? Just making sure. Alright? When you do that, you're going to get, let's see, bring down your 20, put in parentheses. You're going to get 16T squared plus 2 plus 16T. Okay? That is what you'll get. Now, if you take your 20 and multiply it through, you're going to get, 320 T squared plus 320 T plus 40. I took this 20 and I multiplied it through times each term, then bring down your negative 320 T. Bring down your negative 160. Bring down your positive 500. Now if we simplify that, here's what we get. We get composition N of T equals 320 T squared. From this right here, your positive 320T and your negative 320T cancel out. Then you have a positive 40, a negative 160, and a positive 500. Okay, so let's see, 500 minus 160 would be 340, and then 340 plus 40 would be 380. Okay guys, I'm back and I checked my work. Right here, this should have been a 4, okay? So it's no big deal. Don't get upset. Just take your eraser and erase that 2 and make it a 4. So when you take 20 times 4, this becomes an 80. We can easily make that an 80. That's just a little mistake I made right there, which will then give you 420 here, okay? And I do apologize for that. Alright, so there we go. There's your composition. Now, that was pretty simple, but look at part B. Find the time. Oh, no, back to part A. The composition was easy, but this is going to be difficult. Interpret its meaning in the context of the problem. Now, students, if you'll listen, I can make this really simple for you, okay? So please watch carefully. Please notice that your composition took the N function and next went to the T function. So whenever you have this, whenever you have N of T, and then whatever you have here picks up right here, then T of T, your composition is really this. You take this letter here and this letter here. So really your composition is N of T. Now I'm going to go over that again right now. So let me show you this. Let me show you this again. Watch carefully, okay? I'll make this really simple for you. Alright. Now, watch this carefully. Okay, our composition is in function first. So here's my first function. T function second. Circle this function. Now going in order. This is first. This is second. You must go in the right order. Notice it says n of t, and then whatever you have here in the parentheses must come first over here, which it does. Then t of t, when that happens, you take the first letter from here and the last letter from here, and that is what this function is. So n of t is really the same thing as take the first letter here and the last letter here, n of t. So interpret this. What does this composition do for you? Are you serious? Look, guys, what's first? Number of bacteria, little t. So this function here is number of bacteria. That's what N stands for, right? Number of bacteria. Number of bacteria. Based on, now what does little t stand for? Time. So now this composition is really cool. Here I have a function that is number of bacteria based on temperature. Here I have a function, it's temperature based on time. Now I have a function that's bacteria based on time. So what is the meaning? Interpret the meaning. Well, our function is bacteria based on time. I have a function in which you give me time, and I will give you the bacteria. So, look at this. Find the what? Time. When the what? Bacterial count reaches 2,000. So you're dealing with time and number of bacteria. Let's use this function here. No, this function is dealing with bacteria based on temperature. Let's use this function here. No, this is temperature based on time. Let's use this function here. Yes, this function here is number of bacteria based on time. So this function here, I can give you time and you tell me the number of bacteria, or you can give me the number of bacteria and I will tell you the time. And that's what we're going to do here, is just find the time when the bacteria count reaches 2,000. So I'm going to put 2,000 in for my bacteria count and then find the time. Okay? So with that in mind, let's go ahead and do this. Okay, by the way, this should be a little t. That should be a little t right there, because these are little t's down here. Little t, little t. Alright, okay, let's go ahead and do this. Now hopefully, students, you're all caught up on your notes here. So I'm going to go like this to create some space, okay? All I need is this function right up here. And I'm going to put 2,000 in for the bacteria count. Okay? So let's get rid of this so we have some room to work. And here we go. So for my n of t right here, I'm going to put 2,000. Now listen, if I was given time, I would put that in for t over here, but I was given bacterial count. So 2,000 equals 320 t squared plus 420. Well, we know what to do. Bring the 420 over and make it negative. And we're going to get 0, 10, 8, 5, 1. Okay? So 1,580 equals 320 t squared. Now, let's divide both sides by 320. So 1580 divided by 320 would be 4.9375. And now, obviously, take the square root of both sides. And we're going to get 2.22. So approximately 2.2 is your time. So 2 hours and 2/10 of an hour, or 2/10 would be 1/5. So you're looking at about 2 1/5 hours, or 2.2 hours. Okay? next problem here and see what else we can do here. Okay, students, in your notes, I would definitely like you to write page 116, number 82, please. Please write that in your notes, guys. And then, if you want to turn your books to page 116, please feel free to. You don't have to. That's totally up to you, okay? You can look in your book or just follow along here on the screen. Excuse me for yawning. Page 116, number 82. And here we go. You need 50 pounds of two commodities. 50 pounds. Now, one commodity cost this much per pound, and the other commodity cost this much per pound, respectively. So this is the lesser amount, and this is the larger amount, or the more expensive amount. Less expensive, more expensive. Verify that the total cost is 1.25 times x plus 1.60 times 50 minus x, where x is the number of pounds of the less expensive commodity. Now, there's many ways to do this, okay? What I would like to suggest to you, if you're going to verify this, just simply put in some numbers and see if you get out the right answer, okay? For example, let me show you what I mean. It says right here that x is the number of pounds of the less expensive commodity. So, let's just make something up. Let's say we have 30 pounds of the less expensive commodity. So here we go, we're going to put 30 in for x. So we have $1.25 times what right here? 30. That looks really good, doesn't it? I mean, if we're going to have 30 pounds of the less expensive commodity, then we should multiply 30 times $1.25 plus we have $1.60 times, now look what they have here, 50 minus x. Well, your x is 30, 50 minus 30 is 20. That's exactly right, guys. Look, if I'm telling you that the lesser expensive commodity is 30 pounds, then we know the more expensive commodity is 20 pounds, because you're buying how many total pounds? 50. So this model definitely works great, and you confirmed it right here on a test or a quiz. That would be sufficient. You could write me a little note saying 30 pounds is the less expensive, 20 pounds the more expensive, okay? And the more expensive here, the 20 pounds is being multiplied times $1.60, and the 30 pounds is being multiplied by the $1.25. Okay, so there we confirmed it. Now, letter B, find the inverse function of the cost function. So, here we go. Let's find the inverse function of this function right here given to us, alright? Well, you should know what to do, students. Everywhere there's a y, we're going to put an x, and everywhere there's an x, we're going to put a y. So x equals $1.25y plus $1.60, 50 minus y. Okay? Now, let's simplify. X equals $1.25y plus $1.60 times 50. 80 minus $1.60y. So $1.60 times 50, $1.60 times negative y. Alright, and now combine your y terms, and we end up with this. X equals $1.25y. That's incorrect. Sorry about that. X equals $1.25 minus $1.60. So negative 35, negative 0.35 y plus 80. Okay, now we're not done with letter B yet. What does each variable represent in the inverse function? Well, let's go back to the original function. Y is the total cost. So y is the total cost. How did I know that? I will show you right now. I knew that because it says verify the total cost is this right here, and x is the number of pounds of the less expensive commodity. So you put in the lesser, the pounds of the lesser commodity here and here, and then you get out the total cost. Okay, so y is your total cost, x is your lesser commodity. And my pen's really messing up here. Let's get this thing to work here. Alright. Lesser commodity. Okay. So now, guys, they've totally swapped, okay? Everything here is totally, remember, whenever you find an inverse function, everything's backwards. So now x is your what? Total cost. And y is your what? Wow, guys, this pen is really messing up. Hold on a second, please. Y is your lesser commodity, or the pounds of your lesser commodity. Okay, so there we go. Now, use the context of the problem to determine the domain of the inverse function. The domain, okay? Now, this is kind of tricky here because, well, actually it's not. Domain is your x. So, we're going to find the domain of the inverse function. Now, listen to me carefully, students. Usually, if I give you a function like this, the domain would be all real numbers because there's no fractions or square roots or anything that would influence the domain. However, in this case, x is your total cost. Well, now I want to show you something really, really makes sense. Okay, watch this. Think about this. The total cost is going to range between two numbers. You need 50 pounds of two commodities, okay? Well, let's say you wanted 50 pounds of the cheaper commodity. Let's say you wanted all 50 of that. So let's take 50 times $1.25. You get $62.50. Well, that's going to be the lowest your cost would ever be. Your cost cannot be any lower than that. Think about it. You're taking your cheapest commodity, $1.25, and you're multiplying it by 50 pounds. Okay? So your cost will never be lower than that. Now, your cost, if you take the most expensive commodity, $1.60, and multiply that by 50, you're going to get the most that your cost would ever be, and 50 times $1.60 is $80. So, what is the domain of the inverse function? Well, it's this. You've got $62.50 is the smallest your cost could ever be. Okay, $62.50, and the most it could ever be is $80. So put x in the middle. And there's your domain. X has to be greater than or equal to $62.50. It has to be less than or equal to $80. Okay? So, there we go. Alright. Moving on. Determine the number of pounds of the less expensive commodity purchased when the total cost is 73. So we can do this. Here we go. Let's find the number of pounds of the less expensive commodity when the total cost is $73. Now please watch how I do this. I've got a question for you guys, okay? It's saying here, it's saying they want you to find the number of pounds of the less expensive commodity. Well, that's your x, remember. X is the number of pounds of the less expensive commodity. Okay? So they're giving us the total cost, which is $73. So for the y right here, I'm going to put 73. And you know what? I'm thinking, guys, for a second here. I just had a thought, and I don't have many of those. I just had a better idea. Hopefully, this will work. Okay, look at this, guys. Look at this function over here. It's a lot more simplified over here. Okay, so I'm going to use this one over here. It's the exact same thing as this function over here is just simplified. I took my $1.60, I multiplied it through, I combined like terms. I would much rather use this equation here than this whole big equation here, okay? And they're both the same as long as you know in this equation y is your total cost and x is your less commodity. Over here, x is your total cost and y is your less commodity. I'm going to use this one because it's just easier. If you want to use the one over here, this one over here, you'll get the exact same answer, okay? So feel free to do that. Alright, here we go. So x is my total cost. So for total cost, I'm going to put $73. Okay, that's my total cost. I'm going to find the number of pounds of the less expensive commodity, which is y. Y is my less expensive commodity. So bring the 80 over, make it negative, and you'll get negative 7 equals negative 0.35y. Now divide both sides by negative 0.35, so negative 7 divided by negative 0.35 would give you 20. So there we go. We found the pounds of the lesser commodity, 20. Now, what if I would have asked you to find the pounds of the more expensive commodity? Well, the total has to be what? 50. So the more expensive commodity, even though they did not ask for this, we're still going to do it. The more expensive commodity, there would be how many pounds? 30 pounds, because these two together have to add up to 50 pounds. Okay? Alright, guys, pretty good notes, not too difficult. Let's jump into the homework, and if you have any questions, don't hesitate to call or email